For this one, we know we're going to have 4 zeros. When we factor it, we can square x to the fourth because we can divide 4 by 2, and 81 is a perfect square. So we're going to get x squared minus 9, x squared plus 9. I always like to ask myself, can I factor further? X squared minus 9 is still a difference of squares, so that's going to be x plus 3, x minus 3, x squared plus 9, sum of squares, so we can't factor that. Set each factor equal to 0. And solve. Square root both sides, so we get x equals plus or minus 3i. So I have negative 3, I have positive 3, and I have plus or minus 3i. So I have 1, 2, 3, 4. Got them all. Check. For 5, and now I'm going to have 4 zeros again. So we're going to have x squared minus 8, x squared plus 8. I can't square root either of these further, so I'm just going to set them both equal to 0. I'm going to get x equals 8. X squared equals 8 and square root. So we're going to get x equals plus or minus the square root of 8. I know the square root of 8. I'm just going to do it over here. Equals square root of 4, square root of 2. So that's 2 square roots of 2. I'll get x equals plus or minus 2 square roots of 2. I have 2 answers here. X squared equals negative 8. So x is going to be plus or minus the square root of negative 8. I know 8 is 2 square roots of 2, and the negative means there's going to be an I. So plus or minus 2i square roots of 2. So I have 2, 3, 4. I have them all. 2 real irrational and 2 imaginary. My goodness, you can't see the bottoms. Do 2 more by hand and then 2 on Desmos. I have x to the fourth minus 12x squared plus 32 equals 0. So this is a trinomial. It's not my traditional one, but still a trinomial. X to the fourth, x squared, no x's. And I'm going to have x squared minus 8 minus 4. The signs are the same. They're both negative. Cannot factor that further, but I can factor that one further. That is difference of squares, so we get x plus 2, x minus 2. So each factor equal to 0. X squared equals 8. Square root. So we're going to get x equals plus or minus 2 square roots of 2. We just figured that out on the other page. X equals negative 2. And x equals 2. So I have 1, 2, 3, 4. And these are all real. 2 real rational and 2 real irrational. Your irrationals will always come in pairs too, just like your complex. Okay, last problem over here. X to the fourth plus 15x squared plus 56 equals 0. X squared plus 7. X squared plus 8. Cannot factor either of those further, so I'm just going to set them equal to 0. And solve. So x squared equals negative 7 square root. X equals plus or minus I squared to 7. And then we'll have x squared equals negative 8 square root. X equals plus or minus 2i squared to 2. Again, we found that on the other page. So I have 1, 2, 3, 4 imaginary ones here, no real ones.